Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about another programming thread, and that is more extensible as an extension of the programming threads extension. This extension is known as stack and buffer overflow. The stack and buffer overflow and is implemented by the programmers outside the system to gain knowledge of that particular system and then get an exploit code to be executed inside the system. So we will know that how the code is executed in different various ways and how to get recovered from this stack and buffer overflow problems. The stack and buffer overflow problems made the user and the attacker outside the system in a computer networked or a dial-up connection medium to get unauthorized access of particularly a remote system. So in this way, the attacker gain control of that particular remote machine and then get executed an exploited code which is intended only by the attacker. The attacker can do so by gaining first the knowledge about the program and then making a stack and buffer overflow on that program to make its exploited code reach the program's end at the machine and then get it executed as a wrong return address. Say suppose a programmer which is as a result of poor programming make a registration bounce checking on that particular input field. Now the attacker sends a number of fields more than the size of the input field as an input to that particular user program, so that when it reaches the stack of that particular program, it actually contains the exploited code, and then the exploited code is executed at the top of the stack as the returning from that function or the program. So we need to stack and buffer overflow, then position in three conditions. First is overflow an input field, that is an input buffer or a stack, and then it make that is exploited code reach at the particular intended position. Next, it changes the return address with the exploited code's return address at the top of the stack, and then get it loaded for the next step. And the next and last condition is it then get executed the exploited code, reach that particular position at the stack, and after reaching that stack position with an overflow of that data, it execute that particular exploited code at that position, and then the program runs in the particular machine that is intended to be exploited. So performing these three options, the attacker can actually gain the knowledge of that program and then executes the program the way it intended to do so. The result is a new shell or spawning a new operating system's program that was not intended by the user. Say for an example, a web browser program need to enter a username and a password for any user to get login. So the username may contain at least or at most 20 and 5 characters. So in this way, the attacker who wants to gain knowledge of that particular program sends a username size plus another 40 to 50 bytes of sizes, and the last of it contains the code of that exploited program. So when the programmer's input reaches that particular input field of that user button, then the stack will be overflowed with the data, and at last when it's returning from the address of this program, it will contain the return address of the exploited code. And thus the exploited code will be executed at that particular point, which will then get recorded the user program authentication information and coding description of that program, so that now the attacker will change its coding information along its way so that it can get copied of all the information that will be now provided by the user who actually wants to log in that program. So in this way, the attacker makes the stack overflow for an input field of a program. So this can be a result for a poor programming knowledge or a poor programming design. Now if you take care of an example in a programming of C, say for an input that is get from a argv as a command line argument. Now there is an input size made on a buffer size, that is say 25. So if the data that is put by this particular attacker into this buffer size, if it is less than the buffer size specified as a special directory, then it is fine. But as long as it meets the buffer size and exceeds the buffer size's size, then it will start copying the data into the stack until it reaches the stack's return address pointer. So whenever it reaches the stack address pointer of the return and that particular function, then it will copy that particular return address in that particular position on the stack. And then upon exiting on the function, it will return address of that particular function that is exploited, and it is made copy to that stack, so that the argv, the mega of the strcopy function, will get copied the actual data that is intended by the attacker, not by the user. So you can see that is a very designing problem in this type of function. First we will know about what is the programming snippet, and according to that what is the stack and buffer overflow problem. So here we can see that we are declaring a buffer on that particular buffer size which was made previously. So until and unless the buffer is full till the buffer size, there is no problem which can be occurred. So here we are copying the argument v's construction parameters to the buffer. So the argv is constrained with the attacker at the buffer overflow, and now this copy str made that the buffer is overflowed with the exploited program. So upon reading that return 0 from this main function, it will actually execute the exploited code and return the result from that exploited code's execution. Now this strcopy is not a good bounds checking on that particular problem. Whenever we can put and bounds checking that is good enough, that is, we can use an strncopy other than using this strcopy. So here it could be modified with an strncpi buffer argv1. So by this strncpi, we are checking that there should be at least and at most n size of the buffer that is to be done, and that is equals to the buffer size, which is 256. So no more than 256 bytes or characters can be input in that particular argv. So it will not accept after that buffer size. So in this way, we can prevent the good programmers of a stack and a good programming design to make the stack and buffer overflow prevention. Now the poor programming design is not only the issue with the stack and buffer overflow problem. We can know that with the help of a good programming design, we can maintain the integrity of the data that is being produced to the stack and buffers of that particular program. But we need to concern about the architecture of the stack and buffer. That can also be a program problem of that particular stack and buffer overflow. So let us look at the stack program's architecture that is being used by any function within a program to store the values and return it upon the exits of the function. As we know that the locally variables pass to these parameters, which are known as automatic variables, and they are actually stored into the stack to get executed and performed operated on that particular values. So here we can see that the stack is growing from the bottom to the top. So at the top, first we are meeting with the parameters that are local ones, then the automatic variables or the local variables of the function. And after that, we are reaching a frame point, that is the pointers that is made upon reaching this actually automatic variables calculation, and this space is given for growing up the stack for the undefined variables, that is to be the result of the automatic variables operation. Now this saved return point at the frame point, and then it comes to this return address, which is the final one. So if the frame pointer is pointing to this bottom of this tab, that the stack is already performed all the operation, then we can say that the frame pointer reaches the return address. So if it is made like this, that is the space for growing up here, so the exploited program could get easily into here, and that it can grow, reach the safe frame point, and make it the return address of the exploited program as the return address of the intended function. So in this way, the architecture of a stack can also get lost of this particular stack and buffer overflow problems. So now that the attacker or the cracker needs this frame pointer of that particular stack or buffer, and we will place these pointers according to its need that can grow inside this space of the stack that is left for nothing. So in this space, if the architecture is made this way, so we will lose it for the stack and buffer overflow. Other than that, if it is could shrink this space as much as possible, so it will be difficult for the attacker to get into the exploited program loaded into the part of the stack. Now we will see a short snippet of code that can actually happen while reading the directory searches of any operating system. So here we can see that this execvp function is creating a shell of that particular process. So whenever this shell is created, and if this intmain function is running with the system-wide privileges, then the privileges can be misused by the attacker, as well as it can overflow the stack and buffer, as we have previously told that this uses this binsh program, that it is the original binsh program, and by specifying this null with this binsh program, it is specifying another shell spawning which is being done by the attacker. Because it is giving a system-wide permission, so it can be loaded anywhere in the system and can affect it by deleting the file or by manipulating the executable code to exploit it as much as possible, like for using the computer's machine or the shell to do any unwanted work. So now we will move to the stack structure that will be shrinked or grown upon the executable code that is to be performed by the attacker. So the attacker now that copies all the stack information, makes it into the assembly language that is being performed by the assembler, and it removes all the unnecessary features from this assembly language code so that it can copy its executable exploited code in the assembly language instructions. So we need to put a modification on the assembly language instruction that cannot be get rid of any kind of features that is already put by the programmer. So suppose this is the current scenario of the program that we have previously used for using a buffer size for a buffer to get input from the command line argument argv. So first the buffer 0 is accessed, next buffer 1, until and unless buffer for size -1. Now this entire stack is copied by the programmer of this stack and buffer flow attacker, and there it is modified to this. So here we can see all the modified shell code is given of the buffer 0 and buffer 1. Then the no op or the no operation or no instruction is there because it is already removed all the assembly language non-essential features. And after all, the return address is transferred to the address of the modified code that the attacker is put into. So at first it changes the buffer 0, the buffer 1, that are the garbage values that it has produced to reach this one until and unless the buffer is overflowed. And after the buffer is overflowed, in the frame point it has put this no operation that cannot be performed inside that stack. And while reaching the return address, it actually places the address of the modified code, which will get executed upon returning from this stack when the return from the function. Now as we can see that the stack and buffer overflow problem cannot be solved by an exclusive knowledge of the programmer and a skillful of a programmer. Now if the programmer can change this one to detect the stack and buffer flow, then it would require an hard work and definite concentration to look for all the stack and put an perfect inbound combination of this stack directory structure as well as an inbound redo. Now that the stack overflow and buffer overflow can be created by any script kiddie which is known as a normal programmer with no skillful of the computational language, just to recognize the bug in the program and exploit the bug in that particular stack or buffer directory structure to make its program directory as intended by this attacker or this hacker. Now whenever this type of stack and buffer flow occurs, then we can say that these are very difficult to detect and delete it from the programmer. The buffer overflow problem is extremely pernicious because it can be run anywhere over the network and the communication band that is provided on, and it can get affected in any of the machine that is already loaded into this type of buffer overflow program and get intended by the attacker's choice. This stack and buffer overflow, the solution is to place a modification that the execution cannot be done at the stack point. That is, after returning from the stack, that is only the point that the execution can be done for a particular function. In this way, we can stop the attacker or the programmer if they have already placed the modified address in the stack point top, so that also there is an construction or restriction that the program cannot be executed at that point of time, so that the executable code will not be run. This is implemented in many of the operating systems like Windows, Solaris of the new versions, and also the Linux and Unix. Like the x86 and the XP4 of this SP2 Windows operating system uses this type of solution to the software bugs as the stack and overflow of buffer programs. Now this x86 is implemented many of the operating system, as it contains a 512 bytes of this memory, then it can support a larger overflow problem. So these systems must be designed carefully to take care of these programs, which is the main and computational throughput program threat to the actual operating system. That is all for the stack and buffer overflow. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.